Now if you look over the previous example, this method of completing the square to solve quadratic equations allows us to actually come up with a general formula for the solutions of a quadratic equation. And so if you pull out the general principles of the previous calculation, you can figure out what this formula is. And it tells us that the roots of a quadratic equation that looks like this, ax squared plus bx plus c equals 0, where a is non-zero, and b and c, a, b, and c are real numbers. The solutions look like this. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, we said there's either exactly one real solution, no real solutions, or exactly two real solutions. And how could that be? Here we have a description of two numbers. However, you'll see that if b squared minus 4ac is 0, then this just really describes one number. In that case, there would be exactly one real solution. And if b squared minus 4ac is negative, then these are what we call complex numbers. They're not real numbers, so there's no real solution in that case. How do we come up with this formula? Well, I have a proof here, and again we're just pulling out the general principles of the previous calculation and applying them with the a, b, and c in place. So what did we do to solve an equation of the form ax squared plus bx plus c equals 0? We divided by a and translated this equation to x squared, so dividing both sides of this equation by a, we get x squared plus b over ax plus c over a equals 0. Now we can complete the square, so we take half of this term b over a and add the square of that to both sides. That gives us x plus b over 2a squared here. All of this is x plus b over 2a squared plus c over a, which is the constant, equals b over 2a squared on the right. Now we can bring over this c over a, subtract that from both sides, and now we have an equation of the form x plus b over 2a squared equals some constant. The constant looks complicated, but nevertheless it's a constant. Now we're going to tidy up this constant. We're going to add these two fractions. So squaring above and below here, we get that this is b squared over 4a squared minus c over a. And we have a common denominator here, which is 4a squared. And adding this fraction, we have a into 4a squared equals 4a times, so we get minus 4ac over 4a squared as minus c over a. Now it is starting to look like the quadratic formula. We now have an equation x plus b over a squared equals b squared minus 4ac over 4a squared. And this is a simple equation. So we get x plus b over 2a equals plus or minus the square root of this. The square root of b squared minus 4ac is here, and the square root of 4a squared is 2a. Now, if a is negative, why would I write 2a there? Well, we have a plus or minus on top, so it might be minus a, but in that case, we can pair it off with the negative number to get the same solution. So, since I'm talking about two solutions here, a negative in the a would just cancel the negative in the numerator here, so everything would work out in the end. Now subtracting b over 2a from both sides, I get x is equal to all of this minus b over 2a. So that gives us our quadratic formula. X is minus b plus or minus the square root of b squared minus 4ac all over 2a. Now it's always good to think through why formulas are true, especially if you're going to be a math major. Eventually you're going to want to be able to prove things and read proofs and figure out what's going on behind the formulas. So this is a good place to start. To anytime you see a proof, try to read through it and follow the logic, and no matter what you plan to do, that always gives you an idea of where the formula comes from and deepens your understanding of a formula, and also deepens your understanding of where to use it. In Calculus 1 you'll have a lot of formulas, but also a lot of theorems with conditions on the use of the formulas. So certain conditions will have to be satisfied before you can use the formula. And if you have a good look at the proof of the formula, or if you have some knowledge of the proof, then those conditions make more sense, and instead of just trying to memorize them, you have some idea of why those conditions are necessary, and it helps you use the formula, but also it helps commit those conditions to long-term memory. Let's just use this quadratic formula to solve a bunch of quadratic equations. So suppose I want to solve this equation, x plus 3x, x squared plus 3x minus 1 equals 0. And my formula says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's the solution of the equation ax squared plus bx plus c equals 0. Now the question is, what's the a, b, and c here? So we have a doesn't show up, but it's equal to 1, and b is 3, and c is negative 1. And now I have my solutions are x equals minus b plus or minus the square root of b squared, which is 9, minus 4 by 1 by c, which is minus 1, all over 2 times a, which is 2. And this is minus 3 plus or minus the square root of 9 plus 4, and that's 13, all over 2. And that's it. I have two real solutions, and they look like this. They're minus 3 plus the square root of 13 over 2, and minus 3 minus the square root of 13 over 2. I have exactly two real solutions here. Now you might want to try the other two problems and pause the video and maybe come back and look at the solutions. Okay, we're going to use the quadratic formula to solve 2x squared plus 10x plus 10 equals 0. Here I have a is 2, b is 10, and c is 10. And the formula says that the solutions are x equals minus b, which is minus 10, plus or minus the square root of b squared, which is 100, minus 4 by a, which is 2, by c, which is 10, all over 2 times a, which is 2 times 2. Now this is minus 10 plus or minus the square root of 100 minus 4 2's are 8 by 10, so it's minus 80 all over 4. And that's minus 10 plus or minus the square root of 20 over 4. And that's minus 10 plus or minus. Now I can factor 20 into a square times a non-square, in fact a prime, and that's equal to minus 10 plus or minus the square root of 4 times the square root of 5, that's 2 times the square root of 5, all over 4, and I can pull out a 2 here on top, so I can cancel the 2, and that's minus 5 plus or minus the square root of 5 all over 2. And now, that's what my x is, so I have two numbers there, two real numbers, minus 5 plus or minus the square root of 5 over 2, and because the square root of 5 is not a fraction, that's about as simple as I can make those two numbers look. So I have exactly two real solutions here. Okay, let's try the last one. X squared plus 5x minus 4 equals 0. And again I have a equals 1, b equals 5, and c equals minus 4. My solutions are x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That's minus 5 plus or minus the square root of 25 minus 4 by 1 by minus 4 all over 2. And that's equal to minus 5 plus or minus the square root of 25 minus by minus is plus 16 all over 2. And that's equal to minus 5 plus or minus the square root of 25, 35, 41 over 2. So I have two real numbers here. Those are my possible values for x. And again I have exactly two real solutions. In the next section we'll discuss what happens here when I have 0, when I have exactly one real solution, or if this is negative, then I have no real solutions.